Hi everybody, welcome to this new video on the basics of insect nutrition. My name is Larry Koch and I'm the co-founder of Flybox, an insect technology company based out of the UK and in Kenya. We've had lots of experience, fortunately, in building insect farms for ourselves and for customers in the global south and the global north. And today I'm going to give you a small taster session of what's in store for you when it comes to feeding your insects for your insect farm. The species we have chosen to focus on is black soldier fly. That is the majority of insect farmers focus on that species, but a lot of the things I'm going to cover will also make sense for mealworms and possibly other insects as well. So if this is your first time getting into this topic, hopefully this will be everything you need to know to get started. So with that said, let's dive right in. So first of all, we just want to say that, if you're new to the insect farming space, uh, insect nutrition is going to be one of your most is going to be your biggest challenge and also your biggest opportunity. Many insect farming operations, as you can see on the screen right now, have very different business models going in. What at first looks like a simple process or a process that you'd imagine everyone would do more or less the same varies extremely wildly depending on local labor conditions, local feedstock or waste management industry, um, protein requirements, local pricing, logistics, etc., etc. Today, we're obviously focusing on nutrition, but nutrition will be one of those core parts when you're building your business plan that makes or breaks certain business models. And indeed, many, many companies have come and gone and failed in the insect farming space purely down to nutrition. Outside of breeding, nutrition and feedstock economics is going to be basically the principal challenge. So the step for one, let's get into it. First step is we are going to, first of all, be limited by what we can feed our insects based on what is allowed in our country. So on the screen now, you've got like what the UK allows. So first of all, in order to make BSF, black soldier fly protein in the UK, you have to be a feed business operator. And indeed, anyone that you source waste from has to be a feed business operator. This is also very similar in Europe. And there's a similar thing in the US where you need a kind of certification from the person you're getting feedstock for that it is animal feed grade. So really talking about it as a waste isn't actually correct. It's more of a byproduct when it comes to, let's say, the global north in general. There are exceptions. And of course, in many parts of the global south, there's unclear rules about what you can do. In fact, most countries just haven't legislated for BSF or insect farming one way or the other. So it's both an opportunity that you can do what you want, but also a risk that they might turn around at some point and introduce regulations like these. So it's a blessing and a curse if there's not a regulatory formula or ready in your country. But in the UK and in the EU, it's pretty clear. You can use things like brewers' grains, dairy byproducts, vegetable byproducts, bakery products. It's basically like pre-consumer waste, and it's just very much the same thing in Europe. So what they don't want you to use is actual waste that's passed through a digestive system or passed through a kind of messy process, an unhygienic process that wouldn't be fit for animals. And that's very much because animals have been classed, black soldier fly have been classed as farmed animals, and so they are treated the same way other farmed animals are treated. So of course you in your region will have different rules. You can look these up. You can speak to local people in your government, but you absolutely must, or find other insect farmers who are in your country and ask them to kind of tell you about this. Maybe give them something in return, but certainly you have to seek advice on this. Otherwise, you're going to be looking at this space incorrectly right from the beginning. Once you know the limited scope or the expansive scope, if you're lucky, of stuff you can use, now you've got to actually catalog your kind of ingredients and feedstocks. So when I say cataloging, there are kind of logistical and economical data points you want to gather on all of the feedstock around you. So you can imagine a big map. We in our company have a massive map of all the feedstock around the country in the UK, but you need to develop your own one. Where's the feedstock? And then basically create a list of, X company has these 4 feedstocks that they're happy to give me, or 1 feedstock, or whatever it is. And you need to go ahead and find all the biological data about that, which we'll get into in a second, and also the logistical and economical data, because at the end of the day, the feedstock needs to work in a profitable or economic way for your farm as much as it needs to deliver the right nutrients for your insects. Those things are actually related. You can't look at them independently, basically. So you need to go and fill something out like what's on screen now, a big database on Excel, if you can imagine, of everything around you, where it is, how much it is, and all the rest of it. So Dealing with the logistics and economics first, the main things are, you can see in the image, the waste has to have a very low particle size, and it needs to be, you know, nutritionally correct for the insect that you're feeding. They have a nutritional requirement. But in terms of the logistics, we're talking about things like the cost per ton. So what does it actually cost per ton to get the waste? Is it seasonal? So that's like, in many fruits, they are harvested over a part of the year where there's wastage, and then for the rest of the year it's quieter. How available is it, and how consistent or regularly can you actually collect that waste? There's no point having a waste supplier, and you opt for using them because they have very low cost feedstock, but then turns out that they are not reliable with supplying it to you at different times of the year, or they're a small outfit and they keep buggering up their processing lines, and then you have to bear the brunt of that. So you need consistent, reliable feedstock that's ideally not seasonal, or you have a way to manage the seasonality in your feedstock storage. And so that brings you to storage conditions. And then, of course, the distance from the site is going to affect things like the transport price. And then, of course, some waste sources are harder to process. If you get bulky fruits that contain watermelons, you need a dicer or a shredder before it can go into your wet mill. Whereas if you do not have that and you're dealing with brewer's grains, you need, in some cases, just a mixer, and you don't even need to do any pre-processing of the waste. So the processing equipment you're going to select and have to pay for is going to be dictated by the feedstocks you can use. So you need to capture, again, not just the biological data, which we'll get into, but also these economic data points. It's worth saying at this point, this isn't a deep dive into the technologies to do waste processing. There is, of course, another whole video. If you would like me to do that, please share your wish to do so in the comments, and I might do a video on pre-processing technologies to process. How do you process feedstock into a kind of porridge like you're seeing on the screen right now, which is what the BSF need. So either way, you're going to collect all of these data points, and this is going to actually help you whittle down people. So there's no point doing environmental data, which we're going to get to in a second, if the wastes or the feedstock isn't viable from a commercial or relationship point of view. So there's no point going out and testing all the waste around you only to find that only 20% of those you could actually practically use. It's better to get through all the practicalities with the suppliers of waste and then get into testing the ones that look good. And so once you have identified people you could work with that meet the regulations, that have it in the seasonality, quantity, consistency, and you've controlled for some of those factors, then you can obviously get into the testing. And at a minimum, the nutritional testing you want to do of the waste, which is going to, again, enter into your spreadsheet or your feedstock matrix, is going to be things like moisture. You want to know how much protein is in there, fats, carbohydrates, ash fiber, sugars. You're going to want to know some calcium and phosphorus as well, ideally. And that's going to give you, you can just enter those data points in, and that will be used later to formulate feeds. And so in terms of the physical data, obviously insects live inside their feed. So when I say physical data, you could also mean environmental data. So unlike other animals, BSF are living inside the feed. They're not just eating pellets. And so how the waste behaves, is it sticky? Is it thick? Is it difficult to eat or consume for those reasons? That's going to affect your feedstock economics greatly. So you want to record these kind of things like particle size and density and water holding capacity and at a minimum. So once you have this lovely Excel sheet of all the feedstock around you that's viable, that's safe, that's meets the regulatory requirements, that all the nutritional information for, then you can start creating formulas for, or let's say recipes for your black soldier fly. So imagine your black soldier fly. They're trying to hit certain macros because they're going to the gym, and now you have these different ingredients. You can make for them a delicious supper out of these ingredients. That's going to be like the veg, the carbs, and the protein, essentially like any animal. So that's what you're going to do now. And so you're going to, out of your different feedstocks in your matrix, you may have several viable feedstocks, and you want to formulate multiple different potential formulas. Let's say candidate diets, and this could be because you don't really know which ones are going to work well, or you suspect some might work well, others, or it works on paper, but you think it might not work practically. You'll have various, let's say 3, 4, or 5 potentially viable diets. So once you have these, you can see in the images, all you'll need is BSF eggs. So I encourage people who are at this stage, who are building an insect farm, or doing R&D, you do not actually need to invest in a lot of technology at this stage. A small kind of or a container type insect farm is all you need at this stage, or something even smaller. You can even get away with a climate cabinet, which people use for growing plants and things like that. It doesn't have to be, the more controlled the environment, the better. We'll touch on environment at the end, but realistically, you need a space where you can receive eggs. Ideally, just buy eggs from a BSF company that specializes in eggs, and you can then dose that out uh, onto your different formulas that you've formulated from the different diets that you've formulated. Once you've done those small scale trials, and of course there's lots of data you're going to gather on these trials, so you can do many. That image there is from one of our trial centers. You can do many trials for different potential feedstocks, and all simultaneously. And we're only talking about an ice cream tub, that sort of size worth of stuff. So half a kilo of feedstock to do a proper trial, and you're going to measure the success of the larvae, the size of the larvae, the development time of the larvae. There is another video where I can go into that information, but this is an overview video. But suffice to say that you're going to test your larvae, and then you're going to monitor how they perform on these various diets. Once you find a few winners, let's say, or maybe a single standout winner, you may do some tweaking, by the way. So there's no point doing trials like the one you see on screen now, with many tons. There's no point doing that until you've been back and forth with the small scale ice cream tub level type thing and confirmed you've got a winner. And so you may do various iterations. You may cancel some out. You may decide one was nearly good enough, but you actually need to up one ingredient or the other. Again, if you work with a nutritionist, they've seen and done all of this and can interpret the results for you. And so then you're basically going to shortlist the best ones you've got. You're going to rinse and repeat, and you're going to scale it up. So by scaling it up, I'm talking about, at this point, you need something the size of a shipping container, at least, where you can do multiple tons at a time. You want a very controlled environment. The last thing you want to do is, if you're planning to build a big facility, is to be testing things in a poor airflow, poor environment that won't simulate the environment you're going to get in your larger factory. Then you could actually be you could be getting erroneous results. So environment plays a huge role in whether or not feedstock trials go well. So if you have a poor environment when you're doing your trials, it's dumb data. It's not data that you should be acting on, because you weren't controlling for the other variables. So absolutely critical to have a pristine environment when you're doing your trials, or you are going to be wasting a lot of time. And the final step, really, before we close off, is just the product testing. So once you've actually done those large-scale trials, and here now you're confirming what is the yield, the feed conversion of the entire trial. You put 3 tons of this feedstock in that you've been tweaking, and you're getting 600 kilos of live larvae out each cycle. You're getting that consistently. It looks like it's economical. It's not taking you much labor. The processing is going well. The person supplying you with the feedstock is reliable. They're showing up on time. You've tested that relationship. Now you are at the point where you know what feedstock you're going to be using long term, and you should probably start signing long term agreements for people who can supply you that feedstock. And then, of course, your product. So the product that comes out of these trials, you should be testing those too. So the same proximate analyses we talked about before for protein, carbs, fats. The nutritionist on the customer side, so who you're going to be selling the larvae to, like the pet nutritionist or the fish nutritionist, is also wants to create a lovely, because your thing is you're basically using ingredients to create an insect ingredient, and then other people who want to make dog food supper need to use your insect ingredient. So they'll do the same process with that we've just gone through here with your insects, combining it with other ingredients. So you should absolutely get ahead of that and do those tests yourself. Work out what is important to those end customers. What do they actually need to see? Should I be tweaking my feedstock recipe to increase the protein in my larvae, or to decrease the calcium, or whatever it is? You can work with your end customer in a kind of feedback loop to show them, this is what's in it. I can change things. How about we do some trials? What if we tweak things? And that's how you can build trust and link in with your customers. And so you can get a lot of feedback from them. So that also applies to the frass. Many people looking to incorporate frass into new fertilizer products, they also need to do actual trials in the field with particular vegetables in particular scenarios, and that's how you build trust with those customers. And so you have to do this testing. You have to also test for safety because you are now selling an ingredient, a product. It's carefully regulated how kind of safe the larvae, the dried larvae, the oil, the frass you have is. So it's a feedback loop. If your product isn't safe at the end, then it doesn't matter how great your economics are on nutrition, because it's not going to work in the end. So because no one will want an unsafe product. So all of these things are sort of like, it's not a perfect linear line. It's a kind of a circle or a snake that eats its own tail. Um, and that's kind of the overview of what we've just talked about. So it is essentially, you can see on my screen, you gathered all that feedstock information, you built that matrix with all of it. That's the biological, the physical, the nutritional data. You did technical assessments to check it's safe, and all the rest of it. You formulated some candidate diets. You tested those at a small scale. You whittled that down to and perfected the stuff at small scale, so you're very happy with the results that you're getting. Then you move to larger scale trials that you were doing in kind of container loads, and you were able to test your relationship with your potential feedstock suppliers during that process over many cycles. And now you're ready to write contracts to get all the feedstock, and your customers are also happy that they've got a great product from you. And now you do ongoing improvement, with a nutritionist. Ongoing is the way that most companies would do that. So that's basically the overview. I'm going to leave you with a few final thoughts. Ultimately, all of this stuff we're talking about in nutrition has to trace back to financial viability. We want a BSF business that is financially viable. And so, the feedstock is one element. And usually when we are building business models in BSF, everything has to be counted for feedstock. We treat feedstock as its own separate line. So we include the pre-processing equipment, all of the logistics, the fuel, the truck, the people that are dealing with the labor that's dealing with feedstock. All of this stuff has to be carefully, meticulously worked out. And so when you're actually coming up with a feedstock pound per ton, and then extrapolating that up to your farm size, you need to know every single cost in that feedstock, not just what you're paying for it, or if you're getting it for free, great, but then the logistics cost, the processing cost, that all of that stuff needs to be figured out. Then you've got obviously all the other bits that go into your business model, and this is why it's such an important thing. Because if you're off by feedstock, the ratio between dried larvae and feedstock is 15-1. So if your feedstock is going to cost 30 euros a ton, ends up actually needing to cost 60 euros a ton because you buggered something up when you actually got down to it at scale, then your business is basically unviable. So this is why you cannot shortcut the trialing. And even if you've been doing BSF somewhat successfully, you are definitely leaving money on the table by not doing this process thoroughly, rigorously, and ideally supervised and coached by a nutritionist. Okay, and last sort of thing is just about the environment. We didn't cover environment here. I'm going to do a separate video on it at some point. But obviously, as I mentioned, you cannot have a environment that isn't perfect. Otherwise, your trials are going to be incorrect data, basically just faulty data. So very roughly speaking, we should all know this with this channel. You're going to want your nursery, if you're making your own seedlings and not buying them, to be certain degrees, 30 to 32 degrees, 70 to 80% humidity, and then a bit lower for the growing cycles. And at least then you've got a representative kind of temperatures. There are some feedstock, so it depends on what system you're using. If you've got an automated system like the ones we build at Flybox, everything is controlled regardless of what feedstock you use. Some feedstocks run hot, so they actually increase heat internally. Some feedstocks run cold, they actually sort of naturally cool down, maybe from evaporation. Some release a lot of odor and a lot of ammonia. So if you don't have a smart system that can control the temperature at 28 to 30 across your entire container or chamber at every single tray level, well, then half of your trays are going to be heating up too much because your air system isn't working properly, or your sensors are going to be telling you it's 30 degrees, but actually in between the trays it's 40 degrees because you're dealing with a grain-based feedstock, for instance. And again, you're going to be getting faulty data. So you really have to use the right technology, have the right experts if you want actual data to take to the bank. Otherwise, you're at risk, and that might just be what you need to do in the beginning. But when you have the means, definitely come back and do this properly, because you will undoubtedly discover many good things. So that is everything I'll say. If you like this video, if you're with me until now, please go ahead and subscribe on YouTube. That's very helpful for me. Comments, as you can see, I'm replying to all of them. So if you want any particular video, I will do that. Like this video also if you enjoyed it. And I will see you here for the next one. Thank you very much for listening, everyone.